Hello and welcome to another episode of PhaestusFox does Advent of Code 2022. Today's episode will be doing day 3 and 4 as I can continue to try to catch up the fact that I started a few days behind. So, day 3, Rucksack Reorganization. One elf has the important job of loading all the rucksacks with supplies from the for the jungle journey. Unfortunately, this elf did not quite follow the packing instructions, and so a few items need to be reorganized. Each rucksack has 2 large compartments. All items of a given type are meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule, and exactly 1 item of each type per rucksack. The elf has made a list of all the items currently in each rucksack, your puzzle input, but they need your help figuring out the error. Each type of item is identified by a single letter, uppercase or lowercase, which means that capital A is different to lowercase a. The list of items for each rucksack is given as characters all in a single line. A given rucksack allows for the same number of items in each compartment. So the first half of the characters represent the items in the first compartment, and the second half is all the items in the second compartment. They have their example here, and they basically point out that in the first one, P is the only letter that appears in both the first half and the second half. And then to help prioritize the reorganization, each item has been given a priority. Lowercase letters are their representation, 1 through 26, and capital letters are their representation plus 26, so 27 through 52. It wants us to know the total number of unorganized items, so what needs to be rearranged, based on that priority. So in that example above, it's 157. I got 8,085 for mine. And then part 2 is you finished identifying the misplaced items. The elves come to you with another issue. For safety, the elves are divided into groups of 3. Every elf carries in their bag a specific item group. For efficiency, each group of these 3 elves, the bag is identified by a badge, and they are only allowed to carry that item. They have to all be carrying that item. It is if a group has badge type B, all elves have item B on them in one of their in their rucksack, one of the pockets. And at most, 2 elves will be carrying any other item type, which is just saying that there will be exactly 1 duplicate of 3. The problem is they forgot to put the year's updated authenticity sticker on the badge. All the badges need to be pulled out of the rucksacks so that their new authenticity sticker can be attached. Additionally, nobody wrote down which items type corresponds to each group's badges. So the only way to tell the item type is the right one is to find the one item type that is common between all 3 elves in each group. Each set of 3 lines in the input data is a single group, but each group can have a different badge item type. So the above example has 2 groups. The first group is the first 3 lines, and the second group is the second 3 lines. In the first group, the item type that appears 3 times is the letter R, and in the second group, it is capital Z. Then you can calculate the priorities the same as you did previously. So R is 18, Z is 52, so that gives a priority of 70. It now wants you to go through the entire input in those groups of 3 and work out the badges. I got 2,515, and I will show you in my Bevy code how that was implemented. So if we go over to day 3, we have the same setup as all the other days where we implement it and spawn in the day and then read the data. We have the items, which are just random sprites that will be spawned on the screen corresponding to each item type. The bag, which has 1 pocket, which is a U64, and the second pocket, which is also a U64. I'm using this so that I can naively hash the items in each pocket into a specific bit in the 64 bits. I then just have an enum to distinguish the two pockets. And then in bag, I have add item. That takes in a pocket and an item to add and returns a result. It'll return nothing if the item was added without conflict, and the item if the item had a conflict. We then do some checking to make sure that the item is within the range. Then we say if the item type is less than capital Z or equal to capital Z, it's the item's ASCII value minus the ASCII value of A plus 26. Otherwise, it's just the item's ASCII value minus lowercase a. The ID is 1 bit shifted the item type length. This results in the first bit of the value being lowercase a, the second bit being lowercase b, and so on and so on. I then work out which pocket's going into and OR the current pocket's value with the ID. Then quickly I check to see if the two pockets have any bit set in common. If they do have a bit set in common, hence equals not equal to 0, I XOR it to unset it on the second pack. This is so that you don't get multiple conflicts multiple times. And then I return the error item and continue. I then have a new bag function which just initiates both values to 0, and a contains function which returns the ORed value of the two packs to give you the contents of the whole bag. This is relevant for part 2. When we read the data, we do the normal thing of loading up the data from the day. We then create a vector of all the duplicate characters and a list of all the bags. Then for each line, we trim it and work out where its halfway point is by dividing the line by its length by 2. We create a new backpack. We set duplicates to false. This is so that once we've found one duplicate, we don't add that again if there's 2 copies of the duplicate, because there's only one duplicated letter, but it could appear multiple times. Then for each character, we iterate through and enumerate it. And then we pick a pocket based on if that character's position is less than half, it's pocket 1. If it's greater than half, it's pocket 2. Then we insert the item into the bag. If we get an error, and we haven't set duplicate, we put the duplicate value into the dupes list and then set duplicate true. This is, again, just so that we don't add the same item multiple times. And then when we're done adding all the items, we add the backpack to the backpacks list. To calculate the total, I set up RNG for spawning images and getting the length and the width of the screen to position those images. But for the actual calculating, we work out the ID of the character again. We then, again, work out some positioning, which is, this just sets the position either left or right. It's all about just placing images randomly on the screen. And then we say, we spawn that image, and then the total priority is plus or equal the ID, which is all fairly simple and a little bit duplicated because we add them to the backpack because I wanted to be able to render the backpacks. Then we print out the total into the console, and then we start working on the badge totals. The badge totals is just incrementing through all the bags in steps of 3. So we take the number of bags and we step by 3. Then we overlap by getting bag 1 containing it, all its contents. We OR that with the bag's neighbor, and then that bag's neighbor. So basically all sets of 3s, we get all their contents and we OR them all together. And then while the overlap is greater than 0, we bit shift, we increment the bag total by 1, and then bit shift the overlap over by 1. This is the equivalent of counting how many zeros there are before the first bit is set. And then we print that value out. If I go over to my advent calendar and run it, if I go to day 3, So saying this was where all the random images spawning. Each of these images corresponds to an overlapping item, or like the badge item. So these purple candy canes are saying that they all have the same badge ID. And this is all the badges of the items. I also added a button to be able to go back to the main menu. And as you can see, when I go into 3, it prints down here my results. Okay, now we will go on to day 2. Oh, day 4, part 2. Space needs to be cleared before the last of the supplies can be unloaded from the ship. So the elves have been assigned the jobs of cleaning up sections of the camp. Each section of the camp is given a unique ID number, and each elf is assigned a range of IDs. However, as some of the elves compare their section assignments with each other, they notice that many of these sections overlap. To try to quickly find overlaps and reduce duplicate effort, the elves pair up and make a big list out of the 2 combined, your puzzle input. Okay, so the example list uses single digits, but the actual values will be greater. And so some of the pairs I've noticed that they entirely encompass the other one. For example, 2 through 8 fully contains 3 through 7, and 6 through 6 is fully contained within 4 through 6. The pairs with one assigned fully containing the other, one elf in the pair would be exclusively cleaning up sections that have been cleaned by the other. So there seems like this is the place for the most reconsideration. And in this example, there is 2. So, and then it wants to know how many overlaps. I had 651. And then we move on to part 2. It seems like there is still quite a bit of duplicate work planned. Instead, the elves would like to know how many numbers of pairs that overlap at all. In the above example, the first 2 pairs don't overlap, while the rest, all 4 remaining, do. So in this example, there would be 4 overlapping pairs. I got 956 overlapping pairs. Onto the code. I haven't got visuals for this one because I really couldn't come up with anything to draw, but it works the same as all the others. It spawns it all into the world and then reads data. I've generated a range which has a top value and a bottom value, and then you can create a new range from a string input, which splits the string at the dash, finds the first and second value, and puts them into the top and bottom respectively. Or whatever the opposite of respectively is. Top gets second and bottom gets first. Then I have a function called contains, which checks to see if the top is less than or equal to the top of the other, and the bottom is less than or equal to the bottom of the other, which means that you are entirely inside the range of the other. Or self is entirely within the range. Other is entirely within the range of self. And then we have overlap, which is used for part 2, which just checks that if the other's top is greater than or equal to your bottom, and the other's bottom is less than your top, which means that basically you collide on a one-dimensional line. It's a collision check. And that returns true if you're collide at all. So then, again, the very obvious thing of getting the data and reading it, this function is much smaller because it doesn't have any rendering code in it. We then get the number of contained and the number of overlaps initialized at 0. Then for each line we go through, we trim it and split it into the 2 ranges, which we then create new ranges from. Range returns a result because at some point I wanted to have error checking, but didn't get around to it yet. Then if 0 contains 1 or 1 contains 0, because these checks are not exclusive, like if 1 contains 1, it doesn't necessarily mean the other contains it, because if one's larger than the other, makes sense, to me at least. Contains plus equals 1, and then if overlap, and doesn't matter which order you do the overlap in, if one overlaps the other, then the other one overlaps it. So we overlap plus equals 1, and then we print that into our console. And this one doesn't have any visuals, but if I go into the advent calendar and go to 4, it prints out that there is 956 overlaps and 651 of them are full overlaps. So this is part 1's answer, and this is part 2's answer. I hope you've enjoyed. Like, comment, subscribe if you want to see more of the advent of code, and I will see you in the next episode.